Dear students, softwares were categorized into different categories, and the operating system within that category or classification were further classified into user interfaces and kernel. And in the last module, we have discussed user interfaces in details. And in today's module, we will be focusing on kernel. So there are these three important things which a kernel is doing: file manager, device drivers, and memory manager. So let's talk about each of them one by one. So one of the important tasks of a kernel is file management. From file management, we mean the files which are stored on the secondary storage, which means on the hard drive. So on which portion, which of the files are stored? For example, in your computer, there might be multiple files. So those files will be residing in some directory, and in logically, however, physically, they are occupying some sectors within that particular mass storage. And we learned that mass storage has certain tracks and certain sectors in our previous modules. So those sectors and tracks are loaded with certain files, and file manager is tracking all of these files, where they are available, where each file is loaded, which portion of mass storage is available, so that if new file is created by the user, so this means that file could be stored in a location which is available. And then files can be grouped together into directory or folder, as you make many folders and directories within computer. Like if you go into my computer, and if you go into a very specific hard drive, for example D, then within that drive you can create multiple folders, and the files which you have created can be grouped into that kind of folder or directory. So this means the file manager need to take care that which files have been grouped by the user in a certain directory or folder. And user can see directories files using Windows Explorer. So on your computer, you can press Windows E, the button Windows, and then the E together. So this will give you the Windows Explorer. So that Windows Explorer have all the drives, and within the drives all of the directories, folders and files available. So all of such management is done by the file manager, which is one of the core component of kernel. And then there is another important component of kernel which is known as device driver. So you know that software units that communicate with controller are sometimes directly to peripheral devices. Those are known as device drivers. So we learned in previous modules that there is a controller which is communicating with the peripheral devices, and to execute that controller you need a device driver. And this translates generic requests to very specific steps. So maybe there is a generic step, like on your computer you can say control plus P, which means you want to print. But how the printing will be done? So that device driver will translate your request to very specific task. For example, first it will check whether there is a printer attached to your computer, that is accessible, that is on, that is not off, and then there is a page available. And after checking all of these things, then the print which you want to, the document which you want to print should be sent in certain bytes to the printer in certain format. So all of these activities are done by the device driver, which translate your request to generic request to specific steps. And then generic OS which has been built for all of the users of the world can be specialized with the use of device drivers, because if some user has installed some device, so that is the need of that particular user. So that user can install such a device driver, and that device driver will be working for that particular user. So if that device driver, there could be two possibilities, that some of the device drivers are coming within the operating system and some can be installed as a utility afterwards. And then there is another important module known as memory manager. So this is the management of the main memory, your RAM. So we discussed in the computer architecture lectures or modules that your main memory is associated with your CPU, and there are certain registers as well. So all of the management of the memory, that how much free slots are available in the main memory. So for example, we discussed if your main memory is 4 GB, then it means it has 4 billion of bytes available. And how much of those 4 billion bytes are occupied by some programs who are currently running on the CPU, and which of the slots are actually freely available. So that is being coordinated by the memory manager. Then it is saying that single user versus multitasking needs if arise, then which areas are free, which areas are occupied, which memory is assigned to which application. This is also very important. So see, if there are multiple applications running on the same main memory, so each application will have a dedicated portion in the main memory. It will never ever happen, or it should not ever happen, that the memory of one application is directly accessed by the other application. So then you will have many problems. So for example, if you are using a very secure transaction where you are accessing your bank balance, and then there is another application of another user which is residing in the same memory, and if it is allowed that that user can access the memory location of your application, which is the banking application, and that particular location is accessed where your bank balance is written, then you will be in a big trouble, because then user can change your values of bank balance in the main memory, and of course that would be then saved on the secondary memory for future usage. So this means every application will have its own dedicated memory. So that need to be done by the memory manager. And then assigning memory space, whatever memory is available, that need to be assigned to the new applications. And then actions of each program are restricted to its own area. So this is what I was mentioning, that each action of each application should be restricted to get, retrieve data, store data to the memory locations which is accessible to that particular application. And then there is an important concept known as paging. When we are running short of the memory in the RAM and we need more memory, as there are multiple applications running on our CPU and they need more memory, or even if there is only one application which is running on the CPU but it needs more memory, so then basically what computer do, computer tries to take some of the memory by allusion from mass storage, that is known as secondary storage. So from secondary storage it takes some of the memory and it acts as a memory within the RAM. So this means that your RAM is now short and some of the applications, some of the data within the applications need to be stored temporarily into the mass storage and then retrieved afterwards. So such a small data which is stored there is studied under the concept of paging. So when available memory is less than the requirement, OS gets some space from mass storage and rotates data and program back and forth between main memory and mass storage. And this is called paging. And in paging, we have uniform size of the memory. So this means that, for example, if there are different applications running on the main memory, so we divide all of the applications into small sizes which are called pages. We scaled those things into pages, and those pages, some of them are available in the RAM and some of them are available in the secondary storage. And then whenever we need the stored pages from secondary storage, those are retrieved back into the main memory. And such a memory which is taken from mass storage is known as virtual memory. So the memory taken from secondary storage during paging is termed as virtual memory. So if we conclude today's module, we have learned about file managers, about device drivers and memory managers, which are the main and core components of the kernel within operating system.